Welcome to our virtual conference, David, and thank you for joining me for this fireside chat on the future of deep basement design. I wanted
Thank
to
you.
kick off. I wanted to kick off with a slightly broader question to start off with. So, as we now face sort of more space constraints in cities like London, as well as an increase in land value, do you believe that deep basements are sort of the logical choice for the future of building in these built-up areas?
Yes, I think the demand is not going away. I think this year has shown that maybe people are going to change priorities. Maybe there won't be the demand for sort of big office blocks that there has been in the past, but people are still fundamentally going to want to live in cities, and there's not enough space really for anything other than going up and quite possibly down. So I think deep basements are going to be there. They'll still be used. Like a lot of them at the moment are car parks, but again, it's valuable square meterage in a development. So people with those developments will find uses for them and change. Whether it's car parks or gyms or plant rooms or ballrooms or cinemas or whatever it is, people will always find use for them. And having bought that expensive plot of land, they want to get as much out of it as they can. So I think the deep basement as a concept is not going away, no.
And I feel like the word or the term mega basements is something that you see in headlines, and for sort of the layman, it might seem a bit alarming. How can you sort of allay these types of fears for people outside of the engineering community that, it's safe to build things like this?
Yeah, I don't see it as something that should be causing alarm. You see stuff on TV about sort of mega structures, and there seems to be an appetite for that kind of topic. So I don't think of itself the phrase mega basement should cause concern. I think where the problem, if there is one, has come from is, let's say, sensationalist journalism, where people have put a name against a thing and said this is a problem. It's not a problem. I think actually probably it's the reverse. There's something that we should be promoting as achievements. There's a lot of skill and engineering, and it's the usual problem that engineering complains about having the wrong profile or a low profile, and we don't get the credit for what we do, but then we don't actively try and push those topics. So when something comes along that we should be promoting, we just don't. We wait until there's a problem, and then so we only ever see the sort of the downsides and not the upsides. There's a lot of successfully built deep basements going on in cities around the world without any problems at all. But it makes much better headlines to talk about one of these iceberg basements in Kensington where the front of the house falls off. But those are the sort of 5%, or not even that. They're the sort of the 1% end of the curve, which are not really representative at all. So it's like a lot of these things, about education and promoting the story we want, rather than letting a third party who doesn't really understand promote what they want, I guess.
Yeah, I guess it's the nature of the beast for media in a lot of ways, that you don't talk about the achievements, you talk about the issues and problems that then might come up sometimes. Sort of following on from this, with the introduction of deeper basements, because we now, there's always records being broken about it being the deepest basements in London or the UK or in Europe. How are neighboring structures and sort of buildings best protected from excavation works like this?
I think the simple answer is competence. You've got to have the right people doing the job, and it goes all the way through the process. The client needs to make sure that they've got the right team on board, so it's a designer and a contractor working together, and a client needs to understand that this is something which is potentially risky, and if they're going to manage that risk, they have to engage with it and, dare I say it, spend some money to manage that risk, rather than just trying to make that the contractor's problem or the designer's problem or someone else's problem. They have to accept that they're part of this. They've decided to build this big hole in the ground, So they have a responsibility to engage with that, and then manage the process. There's increasing guidance around the sort of specifics of what you actually need to do. New SIRA guides come out. There's already existing documents around design of deep basements and monitoring. There's a lot of historical information out there about best practice, but again, also you need to understand what's around your site. You say you need to protect neighbouring structures or assets, but unless you actually know what's there and what condition it's in, it's very hard to do anything about that. So, what records are there? When do you start engaging with those third parties around you? Because again, if you talk to them and get them involved rather than just treating them as a third party, which is going to be a problem, then you've got a better chance of dealing with issues in a sort of collaborative approach. And I think it is, we need to move away from a sort of it's us and them and it's all contractual and as long as the buck doesn't stop with me, it's okay. That approach needs to go away, and you have to be a lot more collaborative and accept that if everybody goes into it with their eyes open and understands what's going on, you can resolve any problems that come up. If you just go, well, if there's a risk, I'll just make sure that contractually I'm covered and it's not me that has to deal with it, you're not actually trying to mitigate it in the first place. You're just making sure when the music stops, it's not you. And that's not really the approach you want to be taking to getting rid of a risk. So, it's a bit of thought and engagement between all parties, really. The best way to manage that.
Yeah, and I guess then you add to that, utilities and legacy foundations and other infrastructure. From a contractor point of view, how can you sort of assure that you can work around these and assure the sort of piling accuracy as well?
We can always work around them. The problems come up when you don't know that they're there, or more often they're not quite where they're meant to be. People, we piled successfully very close to active rail tunnels. If you know it's there and all the measurements and monitoring in place to make sure there's not a problem, and there isn't, if it's done properly, again, it comes back to competence and experience. You can work really quite close to these assets. The issue is about knowing it's there, and what condition is it in. And as I say, quite often you can't just rely on the records, because even if there are accurate records, when you actually get to site, you find that it's not there. It's half a metre to the left, and that's the difference between there not being a problem and someone getting a phone call. So it's about sort of the records and the investigation. But then after that, you can work pretty close to things. You have to be mindful if you're trying to work around deeper assets, deeper tunnels. You have to start looking at tolerances and making sensible assessments of where you think those piles are going to go. But again, the sort of specification tolerances which are quoted are based on real world experience. So if you work to those, and you build the piles properly or the diaphragm wall properly, whatever it is, you should be within those tolerances or better. And again, it's making sure that the contractor's got the time to do that adjacent to the sensitive asset, rather than putting, like, here's a load of pressure, here's a really tight program. Yes, we know there's assets there, but that's your problem to deal with it. Accept that a little bit more time and care will help mitigate that risk, rather than just trying to pretend that it's not there. It's workmanship. A lot of problems that come up around foundations are based around either unknown information or workmanship issues, which comes down to time and competence quite often.
And if we sort of look at the type of foundations and structures that are used for deep basements and that are, often have quite these multi-story developments above them, are there specific types of structures and foundations that you need to for these type of excavations and builds?
Yeah, I mean, deep basements, by which we're sort of talking 3 levels of basement plus 4 levels, you're really starting to move beyond what can be built with secant piling. And so you're going to tend towards diaphragm walling. And that's a sort of a function of the rigs and tolerances. So normally these are deep basements will be built with diaphragm walling kit, rather than sort of traditional piling and secant piling. Depends exactly on the ground conditions, but that's generally what you're going to have. And then for the foundations underneath, again, a lot of big rotary board piles is quite often the solution, just because it's got to be built from the top beforehand, because trying to get piling rigs down into the excavation afterwards has its own problems. I mean, yes, you can dismantle rigs and put them down there. It's costly, you need big cranes, or if you put small rigs down there, you end up with a lot of piles, which are slow, and if you're in restricted headroom due to propping or floor slabs, again, is that the most cost-effective way of building the foundation? But what we are seeing more of now is a move from maybe discrete pile caps on these sort of setups and more of a piled raft solution. So you can have a sort of a slightly wider spread of piles rather than having very sort of specific clusters. And that's helping with reducing the amount of piles that goes under the foundation itself. But they tend to be fewer, bigger piles rather than lots of little ones as a solution, generally speaking.
And you mentioned, yeah, the ground conditions, of course, being very important there. How would less stable ground conditions affect the designs? Are deep basements possible there? And can, if we put dewatering into this as well, what kind of complications can occur around that then?
Well, there's it just gets more complicated, really. You can obviously still build in less stable ground. We've got colleagues in Singapore, the Far East, where they build in very soft marine clay, Singapore, Bangkok, 20, 30 meters of really soft material. You can do it, you are then very much pushed down the route of using support fluids, and you're very reliant on having good quality control, because if you do have a collapse, it tends to be pretty catastrophic. So it's about understanding the ground as well, because if you think you've got ground which is less stable or more sensitive in some ways, then you really need to understand what you are working with. And so your ground investigation becomes really crucial, because you need to understand just how bad it is, because as the ground becomes less stable, any uncertainty around parameters becomes more and more critical. So any margin of error you might have had is shifting away from you. So you just need to understand the ground a lot better, and be a lot more careful around your predictions of movements and possible impact on surrounding properties, as that ground, because now you can't rely on the ground. Okay, London clay, that's a pretty competent material. You're not too bothered about how it's going to behave. It's understood. If it's a soft marine clay, it is very sensitive. So you really do need to know what you're doing and understand the possible impacts. And then the dewatering, again, as you go deeper, it becomes around, if you start drifting into underlying rock, do you have issues around big fissures that all of a sudden can create large inflows of water, which is very different from just the natural permeability of the ground above. And trying to seal off a big fissure in, say, chalk or something like that is far more difficult than just a normal dewatering scheme. And then, because if you are trying to draw down the water or relieve pressure in a very deep basement, you've got a greater chance of affecting the surrounding area outside the wall, and then inducing movements or settlements because you've drawn down the water outside. So that again is going to come down to understanding the ground conditions. What is the water table? And then if you have gone down the route of dewatering, you've got some practicalities to deal with, because those wells will have to be in use the whole time the excavation is being dug out. So if they've got to be protected to manage that water, because you've now got quite high pressures you're dealing with. And if you run them all the way to the end of the project, at some point you've got to seal them off successfully, so that it don't just become a point of ingress for high pressure water in the future in the basement. So they're useful in terms of getting the water pressure down, but then what is the plan for closing them off to make sure that you don't have a weak point in that base slab. So yeah, dewatering, so it's all manageable, and again, there's a lot of experience, but it's about thinking about how you're going to do it, and the whole life of it, rather than just what are we doing during the excavation. It's to closing it off. Is it going to be part of the permanent solution to deal with the water pressure, or are you going to try and nail the structure down? So it's just design options, and they all come with risks or costs associated.
And when we're looking at the type of ground movement monitoring that is needed for sort of deeper levels or basements with built to deeper levels, how does that change? What type of monitoring is needed then?
It's probably the same. You're looking at movement of the walls. You're looking at settlement of the surrounding area. But there's a shift nowadays to more real-time automated monitoring systems, so that you know what's going on, and that's even more applicable if it's a very deep basement, which potentially is going to affect further away from the site as the hole gets bigger. The zone of influence potentially gets larger and moves away from just the immediate surrounding area. So it allows you to set up quite a sophisticated network of points that you can monitor, and assess and just check as the project's going along what kind of movements you're picking up. But it's not just about purely ground movements. If you're collecting information from the wall movements, sort of inclinometers or strain gauges, and if you're picking up information from any propping about loads, that allows you to match what's happening in the real world to your model, which can then give you confidence in the actual predictions that your model's created. So you can be taking that information, feeding it back into your model to update it and get a feeling for, okay, this is what we thought was going to happen. How good was that estimate? We'll call it an estimate, not a guess. And then you can tweak that as you go along. Say, okay, yes, we're within what we thought was going to happen, or it's looking slightly better, or is it looking slightly worse? So you can use that monitoring information not just as a passive, have we reached the limit? Do we have to stop? But okay, we can use it to actually engage and use it actively to increase the knowledge we've got as we go along. And that may or may not allow you to modify sequences. It probably won't, but if nothing else, it's allowing you to talk to those third parties and say, look, this is what we said was going to happen. You can see it's quite within limits, and people will trust your predictions, and it just builds confidence in the solution you're going along with.
And sort of, you talked about the automation, and also I guess when data is being shared more and more and software is linked together more seamlessly, what do you see as being the future of using new technologies, and how would these perhaps affect the choice of foundations or methods used as well when building deep basements?
And the actual techniques involved with building piles and diaphragm walls have not significantly changed in quite a long time. 50 plus years since, the companies that are around doing it now were around 50 years ago, and we're using similar techniques, but rigs have got more powerful. There's more instrumentation to understand what's going on. There's probably improvements in some of the material side of things, the sort of use of support fluids, different support fluids that might allow us to work in different ground than before. I think probably it's going to be around the sort of the concrete and steel side of things. Concrete technology has changed massively, and there's a lot of pressure now with the recognition that there's a lot of carbon tied up in construction, and certainly the production of cement and reinforcing steel are two big headline figures. So how can we improve that, and how can we reduce those numbers? So the introduction of other materials to change the concrete, or then what that will do with the processes, because as we start changing the concrete mixes, it changes what we can do with it. trying to keep concrete fluid for the length of time required to pour very deep foundations requires very specific mixes, and it's a very different material from sort of concrete that the layman might think about. So those areas are probably mostly where the techniques might change. There's increasing computer power around modeling, and three-dimensional modeling is coming in, and the use of some of that sort of data management will help with maybe coming up with slightly more efficient designs, because again, it's around that design efficiency that allows you to push on further into the ground and demonstrate what's going to happen. So as the sort of computer power improves and sort of soil models are tweaked to go with that, it will allow more confidence in designing these deeper basements, I think. I can't see a new method coming up necessarily. I think there's still going to be the same digging holes and pouring concrete, or a concrete replacement.
Yeah, exactly. And do you see sort of the increased focus on sustainability changing things even further? Will that be one of the key focuses of projects like this? And how does building a deep basement actually fit into that sort of agenda as well?
Yeah, as I said, people try to put less concrete in the ground from a sustainability point of view, but certainly from a contractor side of life, you're always trying to put the minimum of materials in the ground, because that's money. So you're driven by purely sort of economic grounds towards putting the least you can. So that's probably not going to change, but there's probably a more global question over, okay, how are we using these structures, and rather than ripping them down and rebuilding them, how can we ensure that they're more useful in the future? So that existing basement, how can it be repurposed in the future? Now, if that means taking out floor, shifting floor levels, or digging deeper from within inside the basement, how can you do that and reuse the existing structure, which is going to be a function of needing the information of what was built in the first place, an understanding of how it was built, and that's a more sustainable approach than the current buy a plot, rip everything out and start again. And as they start getting deeper and deeper, you're not going to be able to just build another basement around it. If you've already gone down 30 meters, you're going to be looking to say, okay, if I do need another basement, how can I build another 1 or 2 floors from within the existing basement, which is a very different approach from starting from ground level to build. So there'll be pretty new approaches required in that respect. But that's probably the biggest push, I think, in terms of sustainability, is going to be how we can reuse the existing structures and build into them the ability or the knowledge so that you can use them again in the future successfully, which is the biggest stumbling block at the moment to pile foundation reuse. It normally comes down to not necessarily the ability to predict how they'll behave, but who's going to pay for the insurance? Who's going to insure a product from 20 years ago for another 20 years in the future? And that's the next big step to be got over in that side of things.
And do you think the considerations differ greatly between commercial and residential projects when it comes to this kind of building?
Probably not. They're both looking to get an asset into service as quickly as possible. Depending on what their return is per square meter will depend on the budget and how far up or down they need to go. But essentially they're about trying to get from buying the plot to having their end product in place as quickly as possible, and that counts for both, because they're getting revenue in from the end user, whether it's an office block or apartments. And I think going forward you're going to see that those structures are going to be flipped around anyway, and they'll convert one to another. So it's more about having an educated client probably is probably more important than what they're using it for, because you want a client that understands the project rather than someone who's just, well, I'm just buying in a designer and a contractor to build something for me, um, and doesn't really understand what they're doing or where the risks lie. An educated client who can engage all the way through the process will have a better relationship with those contractors and designers, and so they can better manage the risks as the process goes on. And that's probably more important than, as I say, whether it's going to be offices or houses. That doesn't really change people's views.
And sort of on top of all of the things we've discussed here, are there any other factors or potential problems that you think really need to be considered for the deep basement design, especially going forward and as we're going deeper and deeper?
Yeah, and it becomes more important for early engagement with the not just the contractor but the entire project team. We're still trapped a bit in this environment where the sort of procurement process relies on a sort of Dutch auction approach, whereby you keep pushing the price around the market until it gets to a point where no one's prepared to go any lower, and the client goes, right, now I'll build, that's my price. But that's not necessarily going to get you the right team. And if you're starting to go into sort of deeper and deeper basements where potential risks are rising, you want to be engaging with a team early on in the process to go, right, okay, this is the team, this is the designer, this is the contractor, this is what we're going to go and build. Let's now go and build it. And you build enough time in there for value engineering and properly looking at the problems and what the solutions are, rather than pushing it to the very last minute and then trying to sort of jam the jigsaw pieces together against a program and price that might suit what the client's budget is, but is that matched with the actual reality of what they're trying to build? So that's fine if it's normal run of the mill. It's not fine. It's definitely less than ideal. But as basements get deeper, and you're starting to push into areas that other people may not have done, or there's not as much experience around, you need to make sure that you have got the right people and the right team, and not just the person who's willing to do it for the least, because that might be because they don't actually understand what they're getting into. And so that's the risk, sort of the current approach to these sort of things.
And to wrap things up, how deep do you think is too deep then? Where will we see sort of the limit of deep basements?
Well, I don't think there is such a thing as too deep. When we move out of basements and into mining, I guess. But as part of Thames Tideway and Lee Tunnel, we've been building 100-metre deep shafts that then been dug out to over 80 metres. So, okay, that's a big circular hole, but does that really matter? Into the ground doesn't know whether it's a deep shaft or a basement. You're digging these deep holes. So the ability and the knowledge and the technology is there. In terms of for a basement, it's an economic balance. How, as you start going deeper, costs go up. For the project, what does the client need? And that will essentially create the balance point where they decide, okay, that's deep enough. Deep enough for one person may not be deep enough for someone else. So, yeah, it's how do people need to go? There's always records to be broken, and there's always someone. And some people will want to do it just to have a record. They want to have the deepest basement in Europe, as opposed to the tallest tower. So, yeah, I'm not sure that there is a number, to be fair. It's a budgetary issue rather than a technological one, I think.
Yeah, I've been in very deep mines. I don't know if I want to live down there. It's very deep.
Yeah, it's what you're going to use it for. Yeah.
That's great. Did you have any other thoughts or any other things that you might wanted to discuss on this topic still?
No, I think there's quite a lot there. But it'll be interesting to compare with other people's thoughts. You know, everyone's got opinions, so
Hmm.
be interesting to see where the common areas and where the discussion points are. I think probably.
Great.
Yeah.
Well, thank you, David, for the interesting session, and I'm going to now hand over to our next session. Thank you very much.
Okay. Thank you.